All right, good evening, and tonight we're going to be talking about fire protection systems for firefighters. Some forewarning, this is going to be a long one. A lot of definitions, a lot of slides full of definitions, trying to keep the whole death by a PowerPoint, falling asleep in the back of the classroom kind of thing down because we're firefighters. We like pictures, we like excitement. But this is one of the longer chapters, it's one of the more boring chapters. But if we want to cover all the chapters in the book, we got to cover the boring chapters in the book too. So I will do my best. But this would be a good one to break up into a couple days, a couple nights of viewing kind of thing. This is a long and a boring one. So with that disclaimer out of the way, got my note sheet. If you hear paper rustling, some notes. Usually I can kind of play this one off my head, but this one is a lot. So let's go. System components. Fire alarm control panel. That is, before I get too far, because I will be talking about that. I forget how PowerPoint works sometimes. These are the main pieces. Control panel, power supply, initiation devices, notification appliances, and the fire command center. Ooh. Some of you, that makes perfect sense. New people following along. Some of it might be obvious, like initiation devices. All right, power supply. We'll get into all these. Control panel and power supply. The fire alarm control panel functions as the brain of the fire alarm system. It receives, processes, and signals. What signals? Fire alarm pulse stations, smoke detectors, rate of rise detectors. Smarter ones sense, hey, I got a sprinkler head that's broken and flowing water. It takes all that information, processes it, and sounds alarms, set offs, the flashing strobes and buzzers, and sends alarm signals to whoever's receiving the alarm from the system, that kind of thing. Power and alarm circuits are directly connected into the brain. Obviously, everything's got to come together. Power for the system, the alarm systems through the building, detector systems, that kind of thing. More advanced ones, they can also serve as a PA. So, building managers, firefighters later on can tap into the system and, overhead attention, evacuate the building, that kind of thing. They can also be used to control elevators. For example, bring them all down to, the lobby, kind of manually control, when the firefighters activate the little key in the elevator, what they can do, kind of thing. Obviously, the system has primary and secondary power. Primary is coming in from the local power grid, and then backup power. That could be really big batteries, a generator, whatever. So if the main power goes out, the system still has power. And there's an alarm that goes off if the power switches from primary to secondary, just so building maintenance, that kind of thing, knows. That's not going to trigger, a fire alarm to the fire department, and the trucks aren't going to show up, but that's, so they can look at it, keep an eye on it, that kind of thing. Initiating and notification devices. There are manual and automatic, which is quite simply manual. Someone's controlling it. That's the little pull station in the hallway, the little break glass and pull kind of thing, whatever it may be. And automatic, that's the smoke detector, the rate of rise detector, all those fancy detectors that we'll get to in a little while. In notification devices, the audible and visible alarms. That's the big strobe light, the annoying buzzing. A lot of them, if you've ever been around when one of those buzzing ones go off, the wall-mounted ones, the modern ones go off, you can feel it. That is designed that way in your chest, like you're at a concert. That's another notification device. So if someone is blind and deaf, they can feel it, that kind of thing. Trying to provide all the opportunities to notify people that the alarm's going off, kind of thing. And then some of them have a recorded message. Like, I know a couple of the hospitals around here have them. A lot of them might have them where the alarm goes off somewhere in the building and you're in a different building and you hear fire alarm, 3rd floor, east wing, that kind of thing. That's the alarm system going off. And it gets inspected, checked out. And if there's nothing, they, fire alarm, all clear kind of thing. That's the alarm system sending out those messages. Fire Command Center. Bigger buildings, big facilities, paper mills, that kind of thing, might have an actual dedicated Fire Command Center. In other places, there really isn't. Like places I've worked, all this stuff is kind of spread around. So, like where I've worked, the control panel for the fire alarm system is with, where the sprinkler system is built in the maintenance room with the sprinkler supplies because that's convenient. With the building plans, those are in the maintenance room, that kind of thing. Or, the little workshop area. But this is something that can be out there. One whole big dedicated, there's a fire in some part of the building, skyscraper, and, fire chiefs and building managers all come together and kind of plan the fire from a nice, convenient location. Different signaling systems. All systems, when they're installed in a building, kind of create a protected premises. Something is protecting the premises in case of fire. But there's a catch that only notifies the immediate premises. That's like a real old, like, nursing home kind of building. Like, place from the 50s or the 60s, old apartment building where the alarm goes off. One of the residents calls, "Hey, the fire alarm's going off." And then dispatch pages out the fire department and says, "Yeah, someone called, there's a fire alarm going off." That kind of thing. These systems don't send out, an automatic thing to dispatch or the alarm company in a different state where they get a little thing, "Hey, the alarm's going off." This is one of those things where premises only. Couple different terms to kind of remember. These can be in any of the upcoming systems in different, amounts, depending on how the building is, how big it is, what they want to pay for, that kind of thing. Non-coded alarm. Those sound everywhere. That is, I'm going to use a school for an example because it's easy. Someone pulls the fire alarm in the gymnasium. The alarm goes off everywhere, all the hallways, the library, all that kind of stuff. And it's not really specific. Fire department shows up, and that's where, yeah, there's an alarm going off. We don't know if it's a smoke detector or what, or someone pulled an alarm. We got to search the whole building and find what was tripped. Zoned enunciated alarm. It's better. It gives more of a general location where someone pulls the fire alarm in the gymnasium, and the gymnasium is in the west wing of the building. It'll say fire alarm, or the little enunciator panel when you walk into the building, or look at the control panel, will say fire alarm, west wing. Alright, we don't have to search the whole building for what's going on, but we're still going to have to, search a hallway, bunch of rooms, that kind of thing. And then addressable. These are the most direct systems in which it tells you what device was activated. For example, in our gymnasium analogy, fire alarm gets pulled, fire department shows up, looks at the panel, it'll say pull station 13827 was activated. And then they can go, grab the book and go, gymnasium. And they can go gymnasium, east wall. Okay. And they go, yep, it's pulled. Okay, problem solved. Just tells you exactly what the malfunction is, what's going on. Supervising station systems. Continuously monitors remote location and notifies authorities. That is the case of you get paged and dispatch says, yep, we had a call from the alarm company, the fire alarm at the nursing home is going off. Can't contact anybody at the building directly, but the alarm company called and said, yep, it's going off. Auxiliary alarm system. Connected to the municipal system which receives alarm. What that is the fire alarm panel in the building, whatever building you want to imagine, hospital, doesn't matter, is tied into the dispatch kind of emergency communications thing. That is a case where someone dispatch, a little thing goes off at dispatch or what have you, and they go, there's a fire alarm at this building. All right, page out the fire department, that kind of thing. That's directly tied into, the 911 system, if you will. Local energy system versus shunt system. Local energy alarms are able to sound even if they're not directly even if the tie-in to the municipal system goes out. There's a big storm, and for whatever reason, the circuit or the wiring to the dispatch center, there's an interruption somewhere. The local energy system will still alarm. There's a catch because the signal isn't getting out of the building to dispatch. The alarm will only sound at the building, which kind of makes it like the earlier example where the alarm's going off, someone calls dispatch, and they go, all right, we'll send the fire department, that kind of thing. And the shunt system does use the municipal circuit. That's, like I explained earlier, system tells dispatch, hey, there's a fire alarm, page the fire department, dispatch goes, okay, we have an alarm, go here. Proprietary system. It's used in large complexes with a single owner, with a single receiving point, which manages alarms. This is like a really big hospital, maybe older hospital, or like a big paper mill, a big factory where they got on-site security 24/7, keeping an eye on things, and all the fire alarm systems go to the security office where there's always a guy there. And that central point manages the alarms. It may not directly go to dispatch. In fact, it usually doesn't. That's the case of the alarm goes off, the security guy goes, fire alarm's going off. Depending on what the policy may be, they may go check it out. Or they may call dispatch and say, yeah, this is security at the paper mill. We have a fire alarm going off. Can you send the fire department to check it out? That kind of thing. Central station systems. Monitored by a contracted agency, which must be able to manage system issues quickly. This is kind of like your... how do I want to put it? Your alarm system where they contract through like ADT, that kind of thing. A fire alarm company. Key point there, which must be able to manage system issues quickly. Company, we're using ADT because that's the company that springs to mind. Building contracts with them for their fire alarm system. They monitor it. Fire alarm goes off. They try and contact a key holder, or a smoke alarm goes off. They try and contact the key holder. If the key holder answers, hey, we got a fire alarm. All right, I'm on site. I'm not hearing it. I'll go check it out. Or if they can't get a hold of somebody, they call, dispatch. They call, say, hey, can't contact key holder. Send the fire department. We're following our procedures. No one's answering, that kind of thing. Remote receiving. The system is not connected to the emergency center through the alarm system. It's connected by other means, such as a phone line. I got bad news for you. That's about all the book said about it. I tried to decipher that one for a long time, and it wasn't making much sense to me. So this is one of those cases where if you know the secret answer, I'd love to know. That's the book definition, and kind of piecing it together, to me it sounds kind of like the auxiliary alarm from earlier above, but instead of being the alarm panel itself, it's wired into the fire alarm, the dispatch system. It's tied in through a more simple means. So the fire alarm goes off, goes through the little phone line to the dispatch, like any other phone line, and answer the phone, and 123 Main Street, general fire alarm, or something like that, where they can't really see a whole lot of the information. It's more of a less high-tech way to get this alarm over to the proper people. Initiating devices. These are your pull stations, your heat detectors, fusible frangible devices, continuous line, and bimetallic. Now, I believe some of these I go over later, but we'll go through them now, at least briefly. So if I forget or it's not in a later slide, we're all in the loop. Pull stations. Self-explanatory. That's the, in case of fire, pull down or break glass or press a button, hit button or do whatever. Simple stuff. Standard stuff. Heat detectors. Fixed temp and radarize. That one, again, pretty easy to decipher. It's a little device, on the ceiling, wherever they determine to put one. Well, kind of has to be up high because heat rises. And all it is kind of like a yes or no kind of thing with fixed temp. If it's set to go off at 180 degrees, for example, if the temperature is 170, it doesn't do anything. If it reaches 180 or goes up above that, the detector goes off and it sounds the alarm. Radarize is a little different. Radarize is a certain amount, a certain few degrees. And I know this one's later on, but a quick version, that's where it's set to go off based on how rapid the temperature changes. So if it's 60 degrees in a room, and in a minute it jumps up to 80 or 90 degrees, I might set off the thing because it's getting really hot in here really quick. There must be a fire. Those systems can get fooled if they're near a door, where if it's negative 20 out because it's the middle of winter up north and it's a nice toasty 65 degrees inside, and someone opens the door and all of a sudden the temperature drops or rises or does something crazy, that can cause it to go off because it thinks, whoa, temperature changed really quickly, I gotta go off. Fusible frangible devices. I know those are later, but those are like your sprinkler heads. We're going to leave that at that for now. Continuous line. This is good for a large area, for example, like a large, workshop or garage, that kind of thing. It's a pipe along the ceiling with like 2 wires in it. And these 2 wires have a certain electrical current going through them. And when they heat or they're exposed to, heat or fire, the insulation on the wires will change. The properties of the wires themselves will change. It'll change the electrical current running through the wires. And that sets off the alarm because the standard whatever the voltage should be is now different. And bimetallic. These are 2 metals with different properties that warp, making or breaking a circuit. So this would be a case of, these are a little more resistant to the problems like a radarize. Because metal takes time to kind of heat up, They have a certain amount of give, so if someone opens the door, it's warm, okay. The metals may warp, but they won't touch, kind of thing. But if there's a big drastic change in temperature, like 30, 40 degrees, that kind of thing, one metal will expand quicker than the other. They'll touch or break contact. That changes the voltage in the circuit or closes the circuit or opens it, and that sets off the alarm. Here we go. That little guy on the corner, I believe, like a heat detector. Feasible line. That one's a heat detector. Had a quick refresh. Because, honestly, I've never seen one before. They kind of look like smoke detectors, but they don't have, the test button, that kind of thing. So, I've never seen one. Or maybe I have, I just haven't realized. Going doing fire inspections, that kind of thing. But that's what one looks like. More you know. This guy in the middle, that is our fusible link. What that is a little, metal thing in the sprinkler head that holds it shut. And that little metal, that copper-colored device in there is designed in such a way so it melts at a specific temperature. So let's say 180 degrees. Keep it simple. At 180 degrees, that melts, and it lets it's out of the way, and then the little spring plunger can open and water comes out of the sprinkler head. Again, I don't think I've ever seen, or I may have seen like one of those once, or more familiar with the one on the far right, which is our frangible bulb. Again, we're using the 180 as an example, and for the record, that colored liquid in there, they change color. The color is different depending on what temperature. So, sure, someone might know off the top of the header. You can go look, what does a red frangible bulb mean? And I'll say like 160 degrees or whatever it may be. We're using 180 as our example, but the liquid in there is kind of acting, that little vial is acting the same way that the link does when temperature is low. When it gets to that 180, in our example, the liquid expands, it breaks the little vial, the little spring plunger opens, and water comes out of the sprinkler. Oh, here we go, a rate of rise detector. Already talked about that first point. There it is, the 12 to 15 degrees per minute. So big jumps, not like the air conditioner just got turned on kind of thing, or someone opened an oven door in the kitchen. This is big temperatures pretty quick. Pneumatic line detector. Tubing with a flexible diaphragm that responds to excessive air pressure change, monitoring large areas. Air is a gas, and when gases heat, they expand. Colder air is a little more dense and would fit into a smaller space than warm air. If you've ever had like an empty bottle or half-empty bottle of water in your car, and it's really cold outside, it's all sucked in, but you drive with the heat on over time, you can hear the bottle popping and it re-expands because the air and the water in that bottle, especially the air, is warming up and it's expanding and it's refilling the bottle. That's all that does. The air pressure changes because it's getting hot in a room, the diaphragm flexes, and that sets off the alarm. Pneumatic spot. Similar as above, but only in one area. Same flexible diaphragm. The only difference is it's focused like, hanging from a ceiling, and it focuses on this little area. The pneumatic line, that can cover, a big workshop or a big garage. That's a big area kind of thing. Same premise, just local area, big area. Rate compensated. Metal sleeve with electrical contacts. When heated rapidly or past a certain point, sleeve expands, contacts touch, and alarm sounds. That's kind of like that bimetallic we talked about, where it heats really quick, it expands, or if the temperature gets up to our 180 that we've been using so far, it'll then expand, it'll close the circuit, and the alarm goes off. Electronic spot. Rate of rise. Temperature sensitive wires that change current flow based on temperature. Excessive current triggers alarm. It's kind of like our what I call you? Continuous line. Where wires in a little tube, heat, melts insulation, changes the properties of, the metal, lowers their resistance to current, change in electrical flow, alarm sounds. Smoke detectors and alarms. Photoelectric detector. Projected beam of light and a receiver, and refractory application with LED and receiver that detects reflected light in the chamber. That definition is weird. That's because there's two forms of this. The first one is kind of that first part before the comma. There's a receiver on a wall, for example, and a little light source across the room on the other wall across from it. And the sensor sees that light and it goes, all right, I can see the light. Everything's cool. Smoke builds up in the room. It blocks or interferes with the way the light is hitting the sensor, the receiver. And then the sensor goes, wait a minute. I'm not getting... Something's changed. Something's weird with the light source. I'm going to sound an alarm. Because smoke, creates haze, makes things difficult to see, blocks light, that kind of thing. The refractory application with LED and receiver that detects reflected light in a chamber. How that one works, it's a same kind of premise but done a different way. Or instead of having a light over there and a receiver over there, it's one unit with an LED that shines in a specific point. And as long as that light is shining at that specific point, the detector doesn't see it and it goes, no light, I can't see the little LED. It's cool. When smoke gets into the detector, the light hits the little smoke particles and reflects and bounces around. And it can hit the actual receiver and the detector, which then makes the detector go, wait a minute, I'm detecting the LED light. I have to sound an alarm. Ionization detector. Products of combustion attached to ions, reducing conductivity in detector chamber, lowering the voltage, and triggering the alarm, and reset when the smoke is cleared. A lot of fancy words. These are like the ones in your house. These are the ones where it's pizza night at your house, you're making homemade pizzas, and one gets away on you. You open the oven door, big cloud of smoke rolls out, and a few minutes later, the smoke alarm in the living room is going off. That's because normal air is pretty clean. Not a lot of particles in there. And there's a little amount of radioactive material in a smoke detector. And so that's kind of energizing the air, turning it into ions. And so the smoke detector can read these ions and their, electrical current in the detector from them and go, all right, everything's within normal limits, nothing to worry about. When smoke particles or other particles in there, like a lot of dust, get in there, those ions have a little, attach, whether it be the dust or the smoke particles attached to the ions, and then suddenly there's less of these ions that are freely bouncing around, or as often. That lowers the voltage to the receiver, and the smoke alarm goes, uh-oh, the voltage has gone down. I have to sound an alarm because it's outside of normal levels. That's why you hear about, stories or go to the apartment building because someone was taking a real hot, steamy shower, came out of the bathroom, and all the steam went up around the smoke alarm and it went off. Because the smoke alarm doesn't know that it's steam or you burnt a pizza or there's a lot of dust in the air or what have you. If it affects the ions, it affects the smoke detector, and so it'll go off to whatever. Flame detectors detect UV light, ultraviolet, infrared light, IR, or both. These are little, and I have a picture of one of these I know coming up. They're basically a little camera, like your thermal camera on the fire engine for doing salvage overhaul, looking around, that kind of thing. Kind of similar to your thermal, where it's looking for fire. And when it detects, those UV lights in a certain amount or infrared lights kind of thing, they'll go off. But sunlight is ultraviolet, and different, things give off infrared light. So they're very sensitive to, sunlight, welding, bright things. So these usually end up in darker places where they're not going to be, indirect sunlight. There's not a lot of, lights flickering or bright lights, dim lights, light change, that kind of thing. I mean, since they're a camera, they can be blocked. So if there's tall shelving and someone puts a box in front of one, it's not going to do anything because it can't see anywhere. Can't see anything. And fire gas detectors. These are sensitive to products of combustion and can be tailored to detect specific gases. So, these are used in like foundries or welding shops. Places where you can't use a flame detector because there's, molten metal and bright sparks and all that stuff going around. So that will cause the flame detectors to go off. You can't really use ionization because you're welding, there's smoke, there's spatter, there's what have you. Same with foundries, haze in the air, that'll set those off. And with photoelectric, maybe, but there's dust, who knows, machinery moving around could block the light or interfere with it. So these fire gas detectors are good because you can kind of tailor the detector to the gases you don't want. So if you're in a welding shop and you got argon or CO2 floating around or what have you, these gases can go around this detector, go into this detector, and the detector doesn't care. It's not looking for that. Same with the foundry and molten metal, whatever gases might be coming off of that floating around the air, gas detector doesn't care. It's not looking for it. But it'll go off when gases that it's supposed to be looking for go off. So those are harder to fool. They won't go off unless they're, like I said, there's what they're looking for is there. The guy on the left is our IR, our light sensing one, the little camera guy I was talking about. The photosensitive one. And you can see on the front there, that's the little cameras. That's what's looking for the flames or the UV light. And then over on the right side, that is words, a lot of words. Ionization. That's the ionization detector. That's the one in your house. Smoke gets in there, steam gets in there, it goes off. That sucks. Pull the battery even though you shouldn't. Smoke goes away, put the battery back in. Everyone's happy. Sprinkler systems. Complete versus partial coverage. Self-explanatory. Whole building is protected by sprinklers, or only certain high danger areas are protected by sprinkler. Failure is rarely due to the system itself. It's true. The sprinkler system itself is fairly simple. Water goes in, or not, we'll get there. But the system is designed so, it's got to be set off in order to fail. It just doesn't fail for no reason. How they fail, why they fail, that's, sediment in the water lines clogged them. Someone on a forklift hit a sprinkler head and set off the system. We're going to get to valves. So I'll hold on to one, but usually there's some external force causing the system to fail. They just don't, fail like, your car is dead when you get up in the morning kind of thing. Sprinklers, valves, and water flow alarms. We'll get there. Those are kind of the hot points. Those are kind of what we're going to be talking about next. Sprinklers. Fixed nozzles operating individually. Just talked about the forklift scenario. That's kind of what this is. Forklift is driving around. It's a sprinkler head. You go there because there's a water flow alarm. The alarm company called, or the building called, said, yeah, we have a sprinkler going off. Can you come take care of it? You go in. There's a forklift parked there, and there's one sprinkler spraying water everywhere. That's the fixed nozzle operating individually, where the nozzle itself has to trip for water to come out. So the fusible link has to break, the frangible bulb has to break, that kind of thing. Deluge systems. Deluge. Words are hard. These are in more of your high danger areas, aircraft hangars, oil refineries, plants, that kind of thing, where all the sprinkler heads are open and the alarm goes off or a sensor is tripped and water goes in and water's coming out of everywhere. They're open all the time. There's just no water to them until the system is activated. Temperature identification. Kind of hinted on this, and you can kind of see it. Those frangible bulbs, there's a blue one, a red one. You know, those colors, there's, I think, yellow and green as well, and clear. And I think even black. Purple, there's all the colors of the rainbow. And that just is a way to tell what temperature it is. I think I had one question on a test once that was like, what temperature does a red colored sprinkler go off? Other than that, you're not really going to worry about it in the real world kind of thing. Well, you might if you're the one, if you're supposed to be changing the sprinkler heads when you go to deal with water flow and stuff, but follow your procedures kind of thing. Sprinkler head designs. Now, there's a whole lot of designs. And the easy way to tell, is looking at the little reflector here for the water. And the orientation of these pictures actually help. So we're going to start over here on the left. This is a wall mounted. This is one that's not mounted on the ceiling. It's up towards the top of the wall where the wall meets the ceiling. And obviously, it really doesn't do any good for water to be coming out the top, hitting the wall, and not doing anything. So they got this little deflecting shield, so water comes down and it goes out to the sides, but it's not spraying the ceiling, not really accomplishing anything. And up here we have an upright sprinkler head, and you can see the little teeth are pointed down. Think of this kind of like an umbrella. Water comes up, hits this, and gets deflected out the sides and back down. So these sprinkler heads are set up on top of the pipe. These ones here, these are pendant sprinklers. These are the ones that are hanging down from the water pipes. These are the ones that get hit with the ladder or the forklift or what have you and set off the system. And you can see by this shield how it's more of a, flat kind of disc, shooting the water out and breaking up the pattern. Sprinkler storage. If you remember at the beginning when we talked about the fire command post, that's that little red box that has a wrench and spare sprinkler heads. Now, according to the rules, I believe you're supposed, or a place is supposed to have like 3 of each kind in the building. So if they have all of these, they'd have 6 or 9 in the box. 3 of these, 3 of these, and 3 of these. And the wrench and anything else that's important to changing these. Now, it depends on policies. The department may change these. They may shut off the water and kind of help clean up the mess, but it's building maintenance that has to change them, or the building has to contact, whoever installed or services the system, and they have to come out and do it. It's all kind of preferences kind of thing. Actually, we'll go back. I don't have pictures of them, but there are also different ways sprinklers come. So, for example, there's concealed sprinklers. These are in like your apartment buildings, newer hospitals, fancier places where the builders don't want, people walking down the hallway to look up and see all these guys hanging down. So they'll have like little white plastic caps over them so that when the sprinkler goes off, the water comes out, pops the cap off. The sprinkler can do its job, but the average guy walking down the hallway at 2 in the afternoon isn't going to look up and go, oh, there's a sprinkler head there. So it's kind of an interesting little fun fact. If you're, walking around and you look up in the hallway and you just see like a little round white cap about the size of like the lid of a coffee mug kind of thing, or a coffee cup. Just a little circle, like plastic cover. It's probably what that is, especially if, they're equally spaced down the hallway. Another good one is the flush-mounted sprinkler. Very similar, or pretty much similar to the concealed sprinklers, except they don't have the little plastic cap. These are the ones you look up at the ceiling, and the sprinkler head's kind of tucked up in a little cup in the ceiling, so that the guy with the forklift or, people carrying something long down the hallway isn't going to smack into it and break it off. It's a little more protected from incidental damage. And then in-rack sprinklers. These are for like big storage places like lumber yards or big like warehouses with lots of stuff on racks. And that's actual sprinkler systems in the little racks. So when they go off, they can spray, the contents of the shelves. More specialized, but they're out there. Valves. All these coming up are indicating valves. What do they indicate? They indicate whether they're open or closed. So you can look at them and go, oh, that valve is open, there's water going through it, or that one's closed, there's no water past it, kind of thing. There's outside stem and yokes, there's post indicators, there's wall post indicators, and our post indicator valve assembly. A lot of these kind of sound like they're related, and that's because, honestly, most of them are pretty much related. Just kind of context and design kind of dictates what is getting used. For example, this one up here on our left is the outside stem and yoke. This one sitting here I can tell is closed because when these are opened, this threaded rod goes through this body and is connected to the actual valve. Water would be coming through here. Right now it's closed. It stops. Nothing over here. If you open it, the little gate rises and then water can get through. Well, when you open this threaded rod comes up the top of the wheel. There's a little nub right there, and it'll stick out, however far it has to for the valve to be fully open. So there'll be, threaded rod sticking, up past the edge of the picture potentially for how big the valve is, kind of thing. I said earlier, these can have a certain, human-caused failure. The thing with sprinkler systems is, wet systems, which we'll get into, are always full of water. So the valves are always pretty much open. Now, when the building is new and all fresh, people kind of get, all right, well, stem sticking out, whatever, is part of the fire sprinkler system. Older ones, people who, may move into a building and not really know the whole, how the system works, why it is what it is, have been known to, go into the maintenance room. There's this big long stick of threaded rod sticking out, and they bang their knee into it, or it's in the way of, doing some other thing in the building, and the stem's always sticking out. No one touches that valve, so we'll just take the grinder and cut that rod off, and now, sweet. Now I don't have any, big obstruction here. Well, now you need to close it, and you get 3 turns out of it, and you're running out of more threaded rod to run in there, and now your valve is always open because you can't close it. Center guy is our wall post indicator. What this is, these are probably pretty familiar actually. These are the ones you see on like the outside of a big like store, like a Walmart or a big grocery store, that kind of thing. Where you look in this little window, it's kind of hard. Yeah, you can just barely make it out. This little window, it says open in it. This valve right here is open. You close it, little window, it'll say closed. Kind of similar to this. Oh, some of them have the big rod, some of them don't. Older ones probably will have the big rod sticking out of the wall. Other ones, maybe not. All depends, kind of thing. Or newer ones may not. And we got our post indicator. Pretty self-explanatory. Right now, this one's shut. You take the little lever, you turn it. However, I think a lot of them are kind of out and around or kind of up. However it works, the little window will flip to open. That's how you know. Now, one I actually had to look up: post indicator valve assembly, because I've never seen these out in the wild of this type. It's basically this guy right here that we just talked about, except it doesn't have the little window in it that says shutter open. Instead, it's got like a little cage up here and a big disc in it. And so you're going to have to kind of imagine with me here. But let's say the disc is right here, and it's big round. You can see it's the big disc. That means it's closed, kind of thing. When you open it, the disc actually rotates in its little cage, and then you'll just see like the little edge of the disc, like the edge of a coin. Now it's closed or open. Wait. Oop, got confused. Flat would be, parallel this way. So looking like the face of the coin, that's closed. And when you're looking at the edge of a coin, it's open. And it doesn't have the little window. I think a lot of places do this version just because I had to think about that one. It's easier just to look and go, up, closed, or it's open. It says so. So either or, context dependent, but probably the version on the slide. More valves. Fun times. Main drain valve. Lowest point in the system. That's for they have to do major work on the system. The fire alarm system, the sprinklers company comes in, shuts the water off, opens the main drain, empties all the water out of the system. Self-explanatory. Inspector test valve. These are smaller valves that are designed to flow when they're open the same amount of water that one activated sprinkler head in the system will give out. So the inspector can gauge the system, get flow rates from the sprinkler heads, and see, all right, everything's how it should be. There's no drastic change. The water supply to the building hasn't changed. We're suddenly getting 50 gallons per minute less, or some big number. Everything is where it should be. And usually, these inspector test valves and the alarm test valves will often kind of dump out outside the building somewhere, so there's not water all over the floor. In the alarm test valve, that's exactly what it sounds like. It's a little valve to let water out of the main system of the pressure, the actual sprinkler system. So the system, the little controller, the little reader right here, because this is the alarm test valve. Oh no, this is a water flow alarm. Alarm test valve. Short version. Normally it's closed. When they want to test the alarm, they open it. That lets water flow through the system, and it makes the fire alarm system think, I'm flowing water. I have to sound the alarm because there's water flowing. Basically, fooling the system into thinking that a sprinkler is open or what have you. To test, how the alarm system works, if everything's working correctly. Water flow alarms. This is a modern one. This is an old school one. Talk about the more modern one first, just because kind of disappointingly, at least to me, these are the ones you're going to probably run into more often. Now, This sits in the pipe. There's this little flapper valve right here, a little plate of metal. Normally, when the system is all closed, everything's good, water's not flowing anywhere. So this is just sitting there. Little box goes, not moving, everything's cool. Sweet. Break a sprinkler head, or the alarm goes off, or there's an actual fire, or what have you. Water starts flowing through the system and out of the sprinkler head somewhere. The turbulence of the water causes this little flapper valve to move. The little controller here goes, I'm moving, I'm flowing water, I have to sound a water flow alarm. And that, sets off the alarm. The old school fire alarm over here, water flow alarm, is kind of going away. But this is like for old school firefighters or really old buildings. Pipe goes in here. You can see these little fins in here. Kind of like car people, like a turbo on a car. Water goes in. Spin. In normal system, all this is full of water. No water's flowing. It's just sitting there. Everything's cool. You flow water out of a sprinkler head, this direction. Water's coming in. It's moving. It's spinning these little vanes. And it's going out the sprinkler. While as it's spinning, it's ringing a bell in here. So all this is a really big bell. So this is like you see in old, like, I guess movies kind of thing, where the fire trucks pull up to an alarm going off, and there's a bell ringing outside the building. They have to go in, and water's going somewhere. There could be a cracked pipe, a frozen pipe that burst, someone hit a sprinkler head with the forklift, or a real fire. Don't know. This is just saying, hey, there's water flowing in the system. Figure out what's wrong. Water supply to standpipes. Well, standpipes later, sprinkler systems. The minimum supply, regardless of how it comes from, has to be at least 15 psi at the highest sprinkler. It's according to the NFPA book. The minimum flow for the system is dependent on the hazard. If it's a sprinkler system in a house, it'll be, probably pretty low. If it's a sprinkler system, in a wood shop or some big, fuel load place, a big store, probably be a lot higher. It's all dependent on what's in the building. Fire pumps. They assist the system when a certain low pressure is met. As I said before, usually sprinkler systems are connected to the municipal water system in a city. So they're getting, 60 psi or whatever it is coming in, off the street. When let's say there's a big fire and they're flowing a lot, sprinkler heads are open, pressure will go down. So backup fire pumps will go, all right, well, now I've dropped to 20 psi. I got to kick on and help boost that pressure up to where it should be so everything works correctly. Demand for the system may exceed supply. Kind of like with fire pumps, like I said, if you're flowing, all the sprinkler, big, whole building's on fire, all the sprinkler heads are open, there's a pretty good chance you're just going to want more water than the system can give. There comes a point where it's just too much to handle for the system. And then fire department connections. Those are so if the fire department shows up, there is a fire, we want to keep this fire sprinkler system moving along, help it along. They can hook the trucks up into the sprinkler system and help provide that extra pressure, extra water to the system, kind of like the fire pump is trying to do. Then real quick before we talk about this slide, fire department connections, there's usually a certain amount of, you want a truck with, a pump that can provide at least, X amount of PSI, kind of thing, just to kind of help keep the system along. You don't want to put the sad little brush truck at 100 GPM connected up to it and you want, a full engine. Preferably a dedicated engine. So it's not trying to, feed 2 or 3 attack lines and a sprinkler system. You kind of want to have, an engine for the sprinkler system if you're going to go that way. And then an attack engine or other engines. Types of sprinkler systems. Wet versus dry pipe, deluge, pre-action, special extinguishing, and residential. Now, I want to check. Okay. Just going to talk about these ones. Wet versus dry pipe. Wet pipe is like... Wet pipes, kind of self-explanatory, always have water in them up to the sprinkler head. Warm areas, doesn't freeze in the winter. No danger of pipes freezing. Guy on the forklift, hits it with the forklift. It's fun to pick on the forklift guy that hits it because it happens quite a bit. Hits it, and then there's water instantly. Sprinkler head comes off. There's water right there. Water's all over the floor. It's a wet pipe. Those are susceptible to freezing, getting a lot of sediment in there if the water just kind of sits up there. That's why when you see a sprinkler head open, it's like the dirtiest water you've ever seen coming out of them. Because that water may have been up there since 2008 or, 2000 whenever they put the system in and it hasn't been activated. Dry pipe. There is no water in the system. Normally, there's compressed air. And the compressed air keeps a little valve shut that keeps the water back from the system. And the way it's designed is, let's say there's 60 psi of water. The valves are designed so the water has to go through. The valve is designed in such a way so. Pointer. All right. Again, kind of have to visualize with me. Water's coming in towards the right side of the screen. Our dry system's over here on the left side of the screen. The dry system at this valve will have a big opening on the valve. Like, pretty big. The water side will have like a smaller, like half or quarter size. Guesstimating, but you get the idea. Smaller opening on the valve. That is so if there's 60 psi here because of, pressure over, square inches kind of thing, like 15 psi of air can keep 60 psi of water held in check. This is just easier, to maintain in the system than, 70 psi of air for 60 psi of water kind of thing. You can do more with less. These are used like in garages or like overhangs at a hotel, like entryways where in the winter it can freeze, you don't want to break pipes, so there's air in the system. Sprinkler head gets opened or set off or hit with something. There'll be a big rush of air out of the system, and then the water comes out. I've heard, every once in a while someone will ask, air helps feed fire. Is that, are you feeding the fire before you get the water there? Guess, one was technically yes, but really, it's not going to, affect anything in the, moment or two it takes the water to get to the nozzle and flowing kind of thing. Deluge system. Kind of already talked about it with the whole aircraft hangar. The system is open all the time. The alarm gets triggered. All the sprinkler heads are open. Water goes into the system. Water everywhere. Instead of, this head that's broken and that one over there that's broken. This picture is a deluge system. Everything's open. Water goes in. Everything goes off. Pre-action. These are for like sensitive areas, like facilities that, have a lot of water sensitive equipment or, a big packaging facility that does a lot of boxes and that kind of thing. The way these work is they won't send out water right away if it's tripped. So it's kind of like a dry system, but instead of, sprinkler head broken, air comes out, water comes out. It's sprinkler head breaks, alarm. It takes two things to set it off. So we're going to use real fire, for example. Sprinkler head breaks. Okay, that's one. Nothing's happening yet. And one of our earlier detectors, let's say a rate of rise detector, goes off. That's our two things. All right, now the system goes, all right, I have two things telling me there's a fire. Pretty good chance it's a fire. All right, I'll let water into the system, and then water will start to come out of the sprinklers. Now, those two things could be anything. It could be a sprinkler head going off. It could be a sprinkler head in a fire alarm like pull station on a wall, or it could be a smoke detector in a pull station. It just takes two inputs from the system to tell it to put water into the system. Where this helps keep, accidental damage down is, let's say our forklift driver hits one. Well, they hit a sprinkler head, and the system will go, okay, I got a sprinkler head open, but nothing else is telling me to do anything. So it'll send out an alarm saying, so it'll trip kind of a pre-action alarm. Pre-action system. Where there's a certain amount of time for, building maintenance to go, oh no, someone hit the sprinkler system. I don't want to damage all the stuff. I got a few minutes to go tell the system everything's cool. Don't go off. Fix the sprinkler head. No damage done. But they're designed in such a way so that if, a sprinkler head's broken, the little countdown starts. After a while, if no one says, hey, it's cool, don't send water into the system, it'll go air on the side of caution kind of thing, and water goes into the system. But there's time to cancel the false alarm kind of thing. Special extinguishing. Special extinguishing agent is just what it sounds like. Instead of just straight water in the sprinkler system, it could be foam or like a dry or wet chemical agent from kind of like you find in a fire extinguisher sometimes, or clean agent like argon. For areas where like a hangar will usually have like a foam system because aircraft fuel and that kind of stuff. Like computer rooms, like server rooms and big buildings kind of thing. Those will have like a pre-agent system where the alarm goes off, system opens, and gas fills the room, and there's no oxygen anymore, and the fire goes out, and it doesn't get water all over the electrical equipment. You might be able to salvage more from that, or if it's a false alarm and it goes off by accident, then soaking your entire server farm with water, kind of thing. Special note: if you go to a special extinguishing alarm, be on air, be on your air packs, because with water ones you go in, and if there's water, you go, yeah, it's a false alarm, but there's water all over the floor. Now I'm wet. That sucks. Or you go in and there's nothing, and it's like, oh, there's a problem with the system. There's not actually any water flowing. No big deal. Figure it out what the actual problem is. With the clean agent ones, it replaces oxygen. So if you go in there, fire or not, you open the door and you're like, nothing in here. You go in, there's no oxygen because the system's gone off. You and whoever else isn't in the pack, pile up on the floor because you don't have any oxygen going to you. Well, those ones, whether it's like, oh, we know it's a false alarm, or you don't, pack up on those. And then residential. Residential systems have a minimum of 18 gallons per minute per sprinkler. Little amount of water. Again, it's not some big fuel factory. You can get away with, a small amount of water for a small amount of problem. The alarms are designed for residential purposes. A little simpler. Not all the bells and whistles of a big full-size system. It's a little easier to troubleshoot problems. Excuse me. Just in general, user-friendly for the average guy or whoever with it in their house. They're designed to activate quicker than your standard system, so they're designed for at 165. Start a little earlier, maybe protect occupants a little quicker, kind of thing. All about life safety. If it starts at a lower temperature, goes off at a lower temperature, that's potentially longer that, people have to get out of the house or they have fire department show up and rescue. The residential water supply. They could be connected to the normal city water supply. Their sprinkler system, they live in the city, they get their water from the water main just like every other appliance and source of demand of water in their house. There could be on-site pressure tanks, like in rural areas. That's like a big tank on the hill full of water, and when the system goes off, pressure in the tank feeds the system, or a storage tank with a pump. That could be pretty much what it sounds like. Instead of being, a straight tank, there could be a little pump, so it kind of help boost pressure, that kind of thing. Both of these last ones are based on calculations for, the size of your tank. I need a tank that, can hold, blah, blah, blah gallons of water because my house is this big with this many sprinklers and that kind of thing. Standpipes and hose systems. Class 1 systems. 2.5s. I looked this one up. This one's in the book. But they're all 2.5 sized or potentially even larger hose lines for trained responders. These are the ones that don't have, the little fire hose station like the picture here or the little case on the wall with the fire hose in it. It's just, a couple valves on the wall. Fire department shows up, we connect our hoses to them because we can, we're trained to, use the large, high pressure 2.5 sized hoses. There. Class 2, 1.5 lines with hose for either residents or responders. So this is, standpipe comes up and there's a smaller outlet and it's connected to a hose in the little cabinet or the wall rack, that kind of thing. In class 3 is a combination of both of the above. So our picture here, this is a combination. Because it's got the big outlet here and the little outlet with the hose here. Now if it just had this and this same thing on this side, it'd be a class 1. And if it had 2 of these, it'd be a class 2. But a lot of them are a combination. Now, a point on standpipes. Well, not standpipes, but the hose systems. Don't use these. One of the first things you'll learn in an official class, or I'm telling you now, as a heads up, these don't get tested ever. The building is built, they connect to the little single jacket like forestry line, the little plastic nozzle, and go there. Cool. And then it never gets touched ever. So these will break or this will dry rot, and it's just, if you want to use the 1.5 or 1.75, disconnect it, use your own hose, problem solved. Less headache. And another point is, these are kind of going away. There's some doubt, well, not doubt, but the thinking is now that just don't give, the untrained occupant the thought that they can handle the situation. Just have them get out. Types of standpipes. Automatic wet. It's got water in it all the time. Connect the hose to it, open the valve, water comes out. Cool. Automatic dry. Pressurized air until the hose valve is open to protect the system. That's kind of like, these two are like our wet versus dry sprinkler systems. One has water in it all the time. The other has air until, you want to flow water. Semi-automatic dry. Requires activation of a control device to provide water at the connections. That's like our pre-action one. So if you go up and you open the valve, it's not going to do anything. Something else has to tell, okay, we need water in the system, let water out of the system. Manual dry. Dry system requiring supply through FTC. These standpipes have no water in it. The only way that you're getting water out of these standpipes is for the fire truck to show up, connect to the fire department connection, and put water into the system. That's the only way. Unless the truck is connected to it, there's no water in the system. The manual wet. Contains water to monitor for leaks, still requires fire department connection. Same kind of premise as the dry. It has water in it. The water is only there, so, if there's a leak in the system, it'll drip. Someone goes, hey, that pipe is dripping water, get it fixed. Other than that, there's no actual water supply to it, so you still need the fire department connection to get water out of it. Smoke management. Whole premise is to remove or control the spread of smoke in the building. It's there to protect life and property and assist in search and rescue and fire attack. All-inclusive exhaust, pressurization, smoke barriers, fans, and then dedicated versus non-dedicated systems. The whole goal of smoke management is to tell smoke, kind of guide it where you want it to go. Either suck it out of the building, make it just go away, or guide it to places where it's not immediately dangerous to have some smoke building up there. And this gives people, occupants, fresher air for longer, keeps smoke damage down, and then helps us. If there's not a lot of smoke in the building, we can see better to get what we need done. And it's all inclusive. Exhaust fans, sucking air out of the building, blowing it out, smoke goes out, problem solved. Pressurization, pressurizing different parts of the building. The smoke can't go from an area of low pressure to high pressure. Kind of like, clean rooms in hospitals. So by pressurizing, stairwells, you can keep, is a common one. Getting in the stairwell, there's no smoke in there because all the smoke is, in the building. But you're trying to keep the stairways clear so people have air to breathe while they get out. Smoke barriers, that's like these guys over the elevator doors. They're used to seal off, maybe not stairwells because those are evacuation routes, but like elevators where smoke gets in here, it has free reign over all the floors of the building because that's the elevator shaft. There's no barriers in there. But the smoke barrier keeps the smoke out of the elevator system, therefore it keeps it from running rampant throughout the building. And then fans, again. Fans are just trying to dissipate smoke, guide smoke, that kind of thing. Then dedicated systems, just like it sounds. They're smoke control devices. That's all they do. During normal 9 to 5, everything's okay. Operations of a building, they're not active. They're a little less prone to failure. They're less likely to get changed with like normal day-to-day building maintenance, that kind of thing. It's the fire protection system, that's all it is. Then there's non-dedicated systems. These are a little more cost-effective. This is like, using the air conditioning system, the fans for the air conditioning system, also to kind of either do your pressurization or move smoke around or vent certain areas. Systems that in day-to-day operations are being used, but they're also used for smoke management when needed. These are a lot more likely to be changed just because, building maintenance, the HVAC system's broken, we'll deal with it when we deal with it, or something's not right, that kind of thing. Types of systems overall. I kind of talked about specific, devices, but here's more of the methods. Passive. Things that are always functioning, whether it's on or off kind of thing. If there's no on or off, it's just there. This is like, fire stops, firewalls, gaskets around doors, smoke dampers, and HVAC systems. They're present. It doesn't matter if there's smoke or no smoke. The gaskets are still around the door. They're still sealing the door. Doesn't matter. Pressurization. Already talked about it. Ventilation that can create pressure differences. That's that whole smoke can't go from low pressure to high pressure that we talked about. Zone smoke control. The building is divided into zones and pressure used to contain smoke. Obsolete. Like it says, this is going away. This is like kind of like pressurization, but more generalized. For example, if you have a 4-story building, the first floor will be pressurized, separate from the second floor, which is separate than the third floor, which is separate than the fourth floor. You get the picture. Or, the east wing of the building is pressurized different than the west wing of the building. So it's more of a general, keeping individual floors or large areas pressurized from one to the other. Dilution. Using fresh air to keep the air at safe levels. As firefighters, we do dilution a lot. You probably do it at home. You burn a pizza, smoke in the air, you open the window, you turn on the fan, get some fresh air in the room, everything's cool. That's what this is, just a whole fire safety system designed around it. Exhaust. Ventilation along with smoke behavior keeps smoke above occupants. Interesting. So, yes, theory, you could be exhausting smoke outside the building. But, if it's a really big building, that may not be practical. So all exhaust is trying to do is keep it above people. So let's say it's a big atrium, like at a big hotel. There's multiple floors and it's big dome and it's all cool. There's a fire in the atrium. What this system will do was smoke rises. So it'll use ventilation and the fact that smoke rises to try and keep the smoke all the way at the top of the dome. Above the top floor, up by the skylight kind of thing, where down below people can be making their way out and there might be a haze in the air, but the worst of the smoke is out of reach, out of lungs, up there, we got time kind of thing. Opposed airflow uses high velocity air aimed at a fire origin to control smoke, but it must not provide airflow to the fire, because blow on a fire, turn a fan on a fire, it's going to make it worse because you're feeding it. But these use, as it says, think of like, big fans, like long road tunnels, railroad tunnels, subway tunnels, air blowing down the tunnel, pressurizing it, and at the other end of the tunnel, there's an outlet to let all the smoke out into the atmosphere, that kind of thing. So you're blowing all the smoke, down whatever tube we're talking about, and it's going out. And then Firefighters Smoke Control Station. That's kind of like the command post we talked about earlier. But this one is strictly for the smoke systems. This will let firefighters say, all right, we like the ventilation. The ventilation is helping us. We'll keep the fire ventilation system on. We want to use the elevators. We'll turn off the fire curtains over the elevator doors, that kind of thing. Kind of allows firefighters, trained people who know what they're doing, kind of pick and choose what systems to have on versus off, kind of thing. There. Good thing it ended, because I'm starting to get a sore throat after doing 2 of these back to back. But that might have been the worst one of the entire book, just about. There are a couple longer ones, but that was the most, I don't want to put this, definition heavy, if you will, chapter. So, as always, if there's anything you want me to cover specifically, either I haven't yet, or I didn't fully cover it here, or it's just, random questions, throw them at me. Always willing to help teach, and if I did something wrong, I'd like to hear about it, and I can learn from you. That's the whole point of this channel, keeping each other up to speed and fresh. And that, thank you for watching.